Hey Team Electronics and Coding. So today's screencast is an introduction to potentiometers as well as an introduction to the serial monitor on the second page. Okay, let's just jump right into it. We've talked about a couple different functions. Whenever we are communicating with actuators, we write to them. And we've learned a function called digital write. The two arguments that digital write takes are the pin number, the pin number, and then we either write low or high to the actuator that we're writing to. And then we've learned about when we're communicating with sensors, we read them. So the function digital read takes one argument and it's just the pin number. So an actuator that we've digitally written to would be, an example of that would be the LED. And a sensor that we've digitally read would be a button. So the button can record or store, it can read two values, either low or high. And so that's why these are digital functions. They can store two values, either low or high, on or off, 1 or 0. Now, we've also used the function analog write. The two arguments that analog write takes are, just like digital write, the pin number that you're writing to. And then, unlike digital write, which only has one of two options, low or high, analog write, you can write any value between 0 and 255. But that this pin number that you're using, it must be a PWM pin, pulse width modulation, and it has to have a tilde next to it in order to use this pin, or use the function analog write. Okay, Jaden asked the question, where does this number 0 to 255 come from? And I'm going to tell you right now. So 0 to 255 is actually 256 values, because 0 is a value. 256 values. Now, computers store information as either 1 or 0. If you have a 1-bit number, you have one placeholder, and that placeholder can either store a value of 0 or it can store a value of 1. So in a sense, it can store two values total, either 1 or 0, two values. Okay, if you have a 2-bit number, you have two places where you're storing information. The first can either store a 0 or a 1, and the second can either store a 0 or a 1. So if you have the number 0, 0, then that is one number, but you could also have that could store one piece of information. You could also have 1, 0, or you could have 0, 1, or you could have 1, 1. So there are four values that can be stored this way, or recorded this way. If you have a 3-bit number, there are 3 different places where you can store information. And again, they can be 0 or 1, 0 or 1, 0 or 1. And when you add up all of the different values that this can store, there are 8 values. Now, there's a mathematical relationship between the bit number and how many values can be stored, and it is equal to 2 to the bit number. So 2 to the first is equal to 2. 2 to the second is equal to 4, and 2 to the third is equal to 3. So that brings us back to this number here, 256. This is equal to 2 to the 8th. So 0 to 255, representing 256 values, is actually an 8-bit number. Okay, so it's not a random number, 255. There's actually a reason for it. It is an 8-bit number. Okay, which brings me to the second idea that we're introducing today is that we have another function that we're going to be talking about. It is called analog read. Now, analog read takes one argument, just like digital read. It requires the pin number. And the type of sensor, or I guess I should say, unlike digital read, which it can only store or read two different values, this can read of any value between 0 and 1023. Now, this is 1024 values total, which is equal to 2 to the 10th. So this is a 10-bit number. Okay, so analog read, like analog write, means that there's not just two states, but it can be many states. But unlike analog write, which is a function that we send to actuators, analog read is a function that we're going to use to read sensors. And the sensors that we're going to read are called potentiometers. Okay. Oh, one other thing that I want to say. So when we're using the functions digital write and digital read, we are using these pins up here. We can't really see that highlighter. When we're using the function analog write, we have to specifically use the PWM pins. So PWMs are all the ones with the tildes next to them. So 3, 5, 6, 9, 10, and 11. When we use the function analog read, we actually have to use a different set of pins on the Arduino, and we use the analog in pins down here. So any analog sensor that you're going to analog read has to be plugged into the pins down here. Okay, so we're going to be using potentiometers. Potentiometers, the ones in your kit, look like this. This photo is not a great photo because you can't see that on the back here there is another pin. So potentiometers all have 3 pins. This is pin number 1. The pin on the back on our potentiometers is pin 2, and the pin on the front is pin 3. Here's another example of a potentiometer. We have these potentiometers in the classroom. They don't come in your kits though, but I can give you one if you want it. This is pin number 1, this is pin number 2, and this is pin number 3 here. Okay, how do potentiometers work? How do they give us any value between 0 and 1023? Well, if you were to open up a potentiometer and look inside of it, you would see here's pin number 1, here's pin number 2, and here's pin number 3. Now, between connecting pin 1 and pin 3 is a resistive material. And pin number 2 is connected to a dial, and that dial is connected to a wiper. This wiper can move, and so its position on the resistive material can change. If the wiper is all the way next to pin 3, let's say pin 3, we've wired it, so pin 3 is hooked up to 5 volts. And pin 1 is hooked up to ground. So if the wiper is all the way down here, then when we're traveling from 5 volts, we only move through a very small bit of the resistive material before the current moves back down pin 2. And inside of pin 2 is going to be connected to the analog in pin. The Arduino is going to be able to sense the voltage here. Because we've only traveled through a tiny little bit of resistive material, the voltage at this point is going to be very close to 5 volts. So this is going to translate. There is an analog to digital converter is going to translate to the number 1023. So when the wiper is all the way as close as it can be to 5 volts, we're going to get the highest reading on the potentiometer. But let's now imagine that instead of near 5 volts, the wiper is actually very close to the ground. Now, current passing through, or starting at 5 volts, is going to be actually having to travel up all the way through this resistive material before it gets to the wiper and then back down to the Arduino. So this is a much longer journey through the resistive material. And now the reading inside the Arduino is going to be very close to 0 volts. And so this is going to give us a reading of 0 on the potentiometer. If the wiper is halfway, we are going to get a halfway reading between 0 and 5 volts. It would be 2.5, and then it will be a reading halfway between 0 and 1023, so close to 510. Okay, so that is how the potentiometer works. Depending on how much of the resistive material the current has to pass through before it makes its way back to the Arduino determines the value between 0 and 1023. Okay, potentiometers are symmetrical. Components. So just like a resistor, it doesn't matter which way you plug it in. It can be plugged in either direction. So you can see here that we've wired 5 volts on this side and ground on this side, and then our wiper is in the middle. And if you hook up the potentiometer this way, then the largest reading on the potentiometer, 1023, is going to be on this side, and then 0 is going to be on this side. If you hook it up the other way with the power on this leg and the ground on this leg, then 0 is going to be over here, and 1023 is going to be over here. Typically, people hook potentiometers up like this because it's convention that if you turn a dial clockwise, then you turn it up. But you can decide and do it either way. Notice that the wiper, as I said before, has to go back to an analog in pin. If you use a pin up here, it is not going to work. Okay, so the other thing that I want to introduce you to, another function, is the map function. So a map function is very useful because it creates kind of like a ratio between two variables. So if you have a variable, let's call it the input variable. That's going to be the first argument of the map function. The next argument of the map function is the low input value. The next function is the high input value. The next argument is the low, output value. That should be one word. And this is the high output value. Now, the reason why the map function is useful is because imagine we're using a potentiometer and we are writing to an LED. We're going to use the function analog read to read the potentiometer, and this is going to give us a range of values between 0 and 1023. But then we're going to use the function analog write to communicate with the LED. And when we analog write something to the LED, we're actually going to be writing values between 0 and 255. So the map function allows us to create a ratio between the values that we're reading from the potentiometer and the values that we're writing to the LED. So we're going to use this in our next code, this map function. Okay, the last thing that I want to introduce today is the idea of the serial monitor. Now, the serial monitor is a very useful tool for troubleshooting your code or see if you're reading correct values from your sensors or writing correct values to your actuators. Whenever you want to use the serial monitor, you have to use this function serial.begin in your setup. And this initializes the serial monitor, or enables the serial monitor. Basically tells the Arduino that we're going to be using the serial monitor in our code. And then this 9600 value is the baud rate. It's the rate at which the Arduino and the computer communicate with one another. And for our purposes, it will always be 9600. If you mess this up and you write some other number, you're going to get serial readings at weird times, and it's not going to work well. It might not work at all. Okay, so to use the serial monitor, if you look down at the bottom of the code screen, you'll see a little icon for the serial monitor and a little caret. And if you press on it, it will open up the serial monitor here. Now, when you run your code, you will see things printed in the serial monitor if you have told them to print. So, for example, we've told the serial monitor to print high, and so we've printed high in the serial monitor. We're going to be printing much more useful things in the serial monitor, and you will see that in our next activity. Okay, that's all.